Hey, today we're going to be talking about graphing rational functions, actually today and tomorrow. On page 197 of your student journal, there's the introduction. Talks about describing rational function in your own word. You can do that after we go through it today and tomorrow. That might help you summarize it. Good place to take notes on the bottom of the page. But I want you to read through just this core concept about what the parent function of a simple rational function is. Okay? Try to get that focused. All right. So the graph of a parent function, f of x is equal to 1 over x, is a hyperbola. 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 Yes, it's a hyperbola. You don't want to think of it as a disease, as some of you said. Good. It is actually a graph. It's not a bola. Okay? You're not going to catch anything from it. All right. Hey, it consists of two symmetrical parts called branches. That would be these pieces here. The domain and range are all non-zero real numbers. That means that the domain cannot be 0 and the range cannot be 0. And we'll explain. I'll go into further detail on that here in a minute, on why it can't be 0. But in this format, in a simple format, that means you're not adding anything or subtracting anything to the x on the bottom, and you're not adding or subtracting anything outside of this fraction here. Okay? All of the functions that are in the form of g of x equals a over x will have the same asymptotes, domain and range, as this function right here, 1 over x. So the asymptotes, domain, and range will stay the same. In other words, the graph is not shifted at all. Okay, so if you tie this to your previous learning, a couple of things. First, if you look on the next page at the top, you'll notice that we take that a over x, what they had on the previous page, that 1 over, or a over x in that format, and they do minus h and plus k. Well, you hopefully by this time know what h does to your graph and what k does to your graph. What is h going to do? Moving side to side. And what is k going to do? Up and down. Okay, it's going to move it up and down. So it's your vertical and horizontal shifts. When you do that, that means your domain and range and asymptotes will change. When you are not adding and subtracting pieces to it, then your domain and range and asymptotes are going to stay the same. Okay? All right. That being said, we talked about a minute ago, why can't it be 0? Well, your vertical asymptote is right here, going this way. It is when x equals 0. Okay, well, look into this equation. If I put 0 in, I now have f of 0 is equal to 1 over 0. What is 1 over 0? It's undefined, right? That's why it can't be 0. Okay? And then when you start thinking about it, well, then you look at this one. This is your horizontal asymptote. Is it when y equals 0? Well, when I have a fraction, is there any way to make this fraction equal 0? Yeah, if 0 is on the top, however, this fraction doesn't give you a variable on top. Therefore, can 0 be on the top? No. Only 1 can be. Therefore, we will never get to 0 for a y value. Y, or f of x, will never equal 0. Therefore, there's an asymptote there. That is why our domain and range can't be 0. Okay? Think back to quadratics. When we shifted quadratics, what was the point? So our parent function was right here. What was the point that we really focused in on at the beginning to shift? What's the point that we moved? The vertex. Okay? And when we shifted other graphs, we focused in on a point. Like when we did exponential, we focused in on the a term. Try to get us to focus in on a starting point. When you're looking at these graphs, the things that you're focusing on to shift are your asymptotes. The first thing we're going to do is move the asymptotes. you'll notice that it says, when I move this, that's x minus h. Well, my asymptote now becomes x equals h. Whatever h is, that's my asymptote. Okay? Whatever k is, that becomes my horizontal asymptote. So it's important to note that when we start shifting these, we really start focusing on the horizontal and vertical asymptote first. Okay, and they go through those steps there, and we're going to do a bunch of those together as a class and see how that affects things. Yeah. We don't have it. We're not using a name for it, no. Okay. Not that I can recall. I'd have to look that up. No, we're not going to give it a name. Now, some of you are going to actually come up with some other things that you're going to apply here. I'm not going to give those away right now. Okay? Yeah. Correct. If h and k are not there, then the asymptotes are 0, 0. So right now, I mean, technically in this format, a over x minus h, so that's minus 0 plus k, which is also 0. So technically they're there, we just don't have them. They're 0, 0. Yeah? So show me a line that crosses the x-axis with your arm. Show me your arm. A line that would go through the x-axis. Is that a vertical or horizontal? Vertical. So that means your h is your vertical. Okay? And k is your horizontal. Guys, it becomes confusing. So really just think about what type of line would cross x or y. Okay? So if you think about it with your arm, you're like, okay, well, a vertical line will cross the x-axis. Therefore, that's a vertical shift. Okay, it's a vertical asymptote, excuse me. And a horizontal line crosses the y-asymptote, so that's a horizontal asymptote with the y. So horizontal, vertical. Okay, let's go ahead and go through some of these. Number 1 on the bottom of page 198. I want you to read through what you're doing there. Well, that's a good question. So it says to compare it to f of x equals 1 over x. So do you want to graph both? Well, it doesn't say graph both. It would be nice if you had the graph of f of x equals 1 over x. Which, hey, we do. It's on page 197. That is the graph of f of x equals 1 over x. So maybe then, rather than just kind of brushing over it, maybe we should take a look at a few things on it before we start comparing things. So, find some exact points. We know the asymptotes. What are some exact coordinates? Yeah. Good, 1, 1. How about that one?
Negative 1, 1.
Negative 1, negative 1. Okay, 1, 1. All right. That will probably be enough for us right there. Now, I now want you to go back to this one, and I want you to graph just that, and then we can compare it to the other graph here in a minute. All right, so here's what generally happens on these. We get some students that start cranking away on the graphing calculator, throwing that into your y equals menu, and we pull out a table. Okay? Hey, I really don't want you to do that right now. Okay? I want you to get used to using the fractions. I want you to get used to what these graphs are doing and what types of shifts are happening here, or how the characteristics of these graphs are changing based upon the values. So the first thing to note, this up here has changed from a 1 to a 0.25, which is bigger or smaller? Smaller. Usually this is poor form. You usually do not want to leave a decimal in a fraction. You would really like to normally write that. There's a reason they left it like that, which I'll get to here in a minute, but you usually want to write this as 1/4 over x, which is also poor form. You don't want to have a compound fraction. So you would want to write it as 1 over 4x, which we talked about yesterday. Very good. Okay, now, with that being said, the reason they left it here is so that you can compare the 0.25 and the 1. Right? The 1 over x here. It's smaller. Now, when I actually go through and I start plotting points, I would probably start with a table of values. I could start out by picking values for x, and well, actually, we should get the asymptotes first. So the x asymptote is what? 0. There's nothing being added or subtracted on the bottom. It's 0. How about the y asymptote? It's 0. There's nothing out here. So h is 0, k is 0, so it's 0, 0. Those are our asymptotes. So you label those first. Okay? So we put those in. It's easier to just kind of forget about those sometimes when we're dealing with no shifting. Okay? Because your axes are already there. But we got them. Okay? So we get our asymptotes in. After that, you could create a table. What do I mean by creating a table? Well, you could do this. You could say, well, x, y, you guys have to see that. All right, and you'd have 0.25 divided by x. All right, you would put your asymptote in here. You'd say, okay, well, my x asymptote is right here. That's 0. And so I put 0.25 divided by x, which is 0. And I get undefined out. Tell your neighbor why it's undefined. Okay, we cannot divide by 0, therefore it's undefined. So now from there, what do I do? Well, logically, we just pick values on each side, right? So we go 0.25 divided by 1, which is 0.25. So we go here, we go over 1. And we're up to 0.25. Now, I said that specifically in that way for a reason. I went over 1, and I went up to 0.25. Okay? Now, let's say I put negative 1 in, and I get 0.25 divided by negative 1. What do I get out? Good, negative 0.25. So I go over 1 this way, and I go down 0.25. Okay. Now that did not, there's not much going on there. I could then put 2 in and I get 0.25. Am I still on the screen there? Divided by 2, which is, this is 1/4. This is going to be 1 what? This is going to be 1/8. Okay, or 0.125 if you want to think of it that way. Okay, if we leave them all in decimal form. Okay, 0.125. Getting ugly there, but okay, we're here. It's now right there. And are we going to ever hit that asymptote? No. So really, we're not getting much going on there. Even when I put negative 2 in here and I get 0.25 divided by negative 2, I get negative 0.125, which is now right there. What's going to keep happening if I keep going? Well, eventually, and I'm going to move past my table here, eventually, this branch is just going to keep getting infinitely close to the x-axis. So we just kind of draw it like that on both parts here. Now that is not the graph of that. Okay, it just means that if you're building a table, that means you have to start picking values over in between negative 1 and 1, which for you means you're picking fractions. We know 0 is not going to work. We already used it. Right? So you have to try like 1/2. I'm not going to put this in a table, but if I put like 1/2 into this, okay, if I put 1/2 into x, what's 1/4 divided by 1/2? It's what? 1/4 divided by 1/2 is 1/2. So what's 1/4 divided by a negative 1/2? Negative 1/2. Okay? So, look, for those of you who are like, what did you just do? I just put 1/2 in right here for x. So I said x is now 1/2 and negative 1/2, and I solved and I got positive negative 1/2 out. Okay, what if I put 1/4 in? What's a quarter divided by a quarter? Dude, it's 1. Check it out. Yeah, someone said it is just like flip. So I go up 1 and over a quarter. I go down 1 and over a quarter. All right, now I have tried my best. I really have tried my absolute best as I was graphing this to give you hints on how to quickly find points for those branches. Okay, and I'll give you hints on the next one as well eventually. But that is my graph. Now, if I'm comparing that to this, let me see if I can get them both on there. What do you notice about those two pictures? Talk to your neighbor. What's going on? Okay, time is up. Hey, now don't try to get too technical with me. Just picture-wise, what's happening? Chase? Okay, good. The points of the branches are getting closer to the origin, which happens in this case to be our asymptote. So our branches are getting closer to the asymptotes. Is that on purpose? Well, yeah, dude. That 0.25 is telling you it's getting closer. Okay? When will it get farther away? If it's bigger than 1. Okay, well, is number 2 bigger than 1?
Yes.
It's not technically bigger than 1. Okay, so let's modify that. It's the absolute value of the top number is bigger than 1, right? Okay, so that's when you start using that absolute values term. Now, most of you, I heard someone say in here that it's what's going to happen? Yeah, it's a reflection. Well, let's see if that holds true. Just so that we're clear, in both of these graphs, stay with me just for a second before we start that problem. On both of these graphs right here, A was positive. Our 1 was positive. And notice my graph started in the bottom quadrant and ended in the top quadrant 3, or excuse me, quadrant 3 and ended in quadrant what it did this. If I be really simple about it and I say, look, my thinking of slope, which it isn't, but thinking of it, it's rising from left to right. Correct? The graph is starting in this quadrant and ending in that one. It went up. Okay? Ignore what the picture looks like, but started down here, ended up here. This graph also had a positive A. It started down here and ended up here. If that's the case, and this is negative, and you think it's going to switch, where's it going to start and where's it going to end? Before you graph it, tell your neighbor where you think it'll start and where do you think it'll end. Okay, now I want you to actually graph it and see if you are correct. Find your asymptotes first. Did you? Hey, did everyone get those asymptotes?
Yes. The only way the asymptote changes is if there's a transformation, right? Or
Translation, yeah. All right. Hey, when I plug in 1, what do I get out? -2. So that means when I go over 1, I go down 2. When I plug in 2 for x, notice when I plug in 2, what do I get out? -1. So when I go over 2, I go down. I am doing my best to give you so many good hints here. Come on. Okay? When I plug in -1 for x, what do I get out? Negative 2 times negative, or divided by negative 1 is positive 2. So when I go over 1, I go up 2. When I put negative 2 in for x, what do I get out? 1. So I go over 2 and I go up 1. Now, does anyone see the shortcut? Okay, let me go back to this. When I plugged in 1 for x on this, 1 for x on this one, what did I get out? I got 0.25 out. So I went over 1 and up 0.25. When I plugged in 0.25 for x, what did I get out? 1. So I went up 1 and over 0.25. Yeah? Sure, there for sure is a reflection of this branch to this one. They are symmetrical. Yes. Hey guys, your A term right here, if A is just a whole number value like that, if you just focus on that, that tells you how far, like when I go over 1, it tells me how much I'm going down. It'll also tell me if I go down 1, it'll tell me how much I'm going over. Okay? That's why when this number gets really, really, really close to 0, you are getting really, really, really close to the asymptote. Because as you go over 1, you're only going away from the asymptote that much. You're going away from this asymptote and that asymptote. Okay? That's what that's telling you you're moving. Now when I'm graphing this, if I have those 2 points, I know that it's going to curve around there. It is not connect the dots. It is not this. Do not give me that ugly curve, please. All right? Make it a curve, or if you are not going to make a curve, then make sure you calculate the point in between. Okay? So go through those 2 points, round it off, and make sure it approaches the asymptotes. Otherwise, you got to calculate more points. I really do prefer 3 points in there. So really, it'd be nice for you to calculate this one right here, which would give you that and that. Okay? Okay, comparing it to the graph of y equals 1 over x, what happens? Gets further away from the asymptotes. Y equals 1 over x. The closest point to the asymptotes are right there. Okay? That's the y equals 1 over x. It also, that would be negative 1 over x. So 1 over x would actually have that point and that point, right? So what else did it do? It reflected it. Okay? It either reflected this way and that way. It reflected it. It moved our branches from quadrant 1 and 4, or 1 and 3 to 2 and 4. It means that if I put like a line here, it is falling from left to right because of that negative symbol up there. Okay? Questions? All right. Moving on. I want you guys to take a look at the next 2 on the next page.
All right, now we have Asymptotes.
Woohoo! Hey, we get some HK shifts. Nice. Hey, HK. All right. HK.
Yeah, who cares?
Who cares? I care. Okay, but HK. All right. There we go. Try number 3. Okay, first step is to come up with the asymptotes. X equals. Yeah, it equals 3, right? It's what makes that 0. It's 3. Okay? What's K, or what's Y equal? 5. In sync. Oh. 5. Okay, so I know my asymptotes are shifted towards the right and up. So I am going to send my axes to the left and down so I can fit that graph on here. Otherwise, my graph is not going to fit. I should really start putting arrows on my axes. There we go. Okay, so my asymptotes at x equals 3. And y equals 5. My goodness, I'm having a hard time drawing little straight lines. Just for you know, x equals 3, y equals 5. Okay. How far away from the asymptotes are going to be? I'm going to go over 1 and? Up 1. Uh-oh. We can't go up 1 and over 1. We get the same point. We only get 1 point out of that deal. What a ripoff. Okay? How about here? We go down 1 over 1, or over 1 down 1. Same thing. What a ripoff. Okay, how do I know I'm in the correct quadrants, Jackson? Jackson, put that away. Pay attention. How do I know I'm in the correct quadrants? Someone else. Scarlett. It's because that's positive, correct. Our fractional piece is positive, therefore it's going up from left to right. Start in the bottom left and in the top right. Okay? Look, we're going to have to find more points on this. We can't just say, okay, it hits right there. I mean, it's 1 unit away, but... Oh my gosh, wait. Oh man. Oh my gosh, you're coming up with the good questions. Oh her gosh. Did everyone hear her question? Okay. So let's Hallie, we're going to come back to that here in a second, okay? So this point right here and this point we've got. Now, if I actually calculate what 1, 2, 3, 4, 5 is, what would 5 be if I put it in for x? 5 minus 3, 2, 1.5 plus 5 is, or 1/2 plus 5 is 5.5. Now, if that's half, what's this one going to hit at? Symmetrical, the branches. So if this is 2 over and up 1/2. Okay, now that's if we know for sure that this is the correct point there, okay, which it is. So now look, we can actually calculate what 1, 2, 3, 3.5 is. If I put 3.5 in, I mean that's 3.5 minus 3, which is 1/2. And 1 divided by half is, how many halves in 1? 2. 2 plus 5 is 7. So 3.5, 1, 2, 3, 4, 5, 6, 7. Woohoo! Hey, we're right. Okay? Now look, we can go here, and if we put 1 in, what's 1 minus 4? Or 1 minus 3? Negative 2. That gives us negative 1/2 plus 5. 4.5. All right, so we're right there. And this point, I promise, is right there. We could actually calculate it. Okay? Now, if I'm creating my curve, it's approaching the asymptotes, going through those points. There we've got it. Approaching the asymptotes, going through those points. I want to go back to what Hallie said now. Hallie said, oh, if it's just moved up, I can't remember exactly how she said it. Oh my gosh, it was an oh my gosh. Oh her gosh, wait. Hey, does anyone, you guys, are you following what she's saying? I know that
It's the same as 1 over x, but just with a different.
You just move the point.
these points right here, this is the graph of 1 over x. These points right here are those exact same points in relation to the asymptotes.
So if we take the asymptote and like act like that's the axis, then it's just the same.
Correct. If you take the asymptotes and pretend like they're your axes, it's kind of the same thing.
Can't you use like the asymptotes and like you move it over 3 and up each point like over 3 and up?
Yep.
Yeah.
Hey,
That'd be hard
guys,
to
stay here.
Yeah.
All right? So the other way to think about it is how Derek just summarized it. Now look, you could think of it this way. You graph the original 1 over x, which is this piece without the h and k, and then each of these points are going over 3 and up 5, which is that point. And over 3 and up 5. So, however you want to think about it, these pictures are the same. It's just this whole piece right here has just been slid over 3 and up 5. Okay? Very good. If you're like, that doesn't make any sense to me, make your table. Okay? That's fine. I want you to try number 4, though. Tell your neighbor what it's going... Oh, whoa, before we do that, we need to find our domain and range. List the domain and list the range first. Okay, domain. X is...
Oh, greater and less.
All right, hold on.
Except for 3.
Good. Hey, it's all real numbers. Those of you said all real numbers.
Oh.
Except for?
3.
Except for 3.
Yeah, okay.
Oh, I see.
All real numbers except x equals 3. What's our range? Very good. All real numbers except y equals 5. That's where they're undefined. That's where our asymptotes are. Those values cannot exist. We cannot reach those values. Okay. Hey, if you have questions on that, ask me as I walk around, but I need you to start number 4. Describe to your neighbor what that graph's going to look like first. Okay, remember, always start with your asymptotes. I know you're not done yet, but x equals what? 0, and y equals? -4. That means my graph is not moving left or right, but it is shifting down. Therefore, my axes, when I put them on here, should be, you should move them up. That way you can see your graph. So if your picture of your graph is going downward, move your axes up so you can see it. It's like you're dragging, like if you're on the computer, you're dragging your picture there. Okay? How does that -3 help me? Hey, you're going to be 3 units away from each of those axes, or those asymptotes. So if I go 1, 2, 3, I go down 1. If I go 1, 2, 3, I go over 1. That's only when that's just a constant number up on top. Now, if that's confusing, remember, you can always make your table of values. You could just make x, y, -3 over x minus 4. And then plug everything in. 0 we know is undefined. Or not, yeah, 0 is undefined, so when I put 1 in, I get -3 over 1 minus 4, or -7. That's that point there. I should, even though I have those, I have a x value in between. I really need to test that point. So if I put 2 in, That's negative 3/2 minus 4, which is negative 6.5. Or negative, excuse me, 5.5. Thank you. Okay, so that would be right there. Remember, the branches are symmetrical, so this point right here would actually, if I were to put, let me put my negative 1 in. Okay, that gives me 3 minus 4, negative 1. Okay, so that's that one. When I put negative 2 in, that's going to give me that symmetrical point. So I get negative 3 over negative 2 minus 4, which is 1.5 minus 4, or 2.5. Negative 2.5, excuse me. So that would be right there. And so you can start seeing that curve. Bless you. Okay, it moved away from the asymptotes, right? All right. Hey, domain? And range? All right, domain and range there. All right. Guys, if you need to use the table, use the table. If you don't, then don't. That is where we're going to stop for today. Tomorrow we'll pick up, notice tomorrow stuff. Woohoo!